Section 10.1 for statistics, the language of hypothesis testing. According to the dictionary.com, a hypothesis is a proposition assumed as a premise in an argument. The word hypothesis comes from the Greek word, I'm not even going to try to say that, hypothesenai or something. So, hypothesis. All right, y'all can make fun of me. Which means to suppose. The definition of hypothesis in statistics is given next. So all of these blanks are the same thing, hypothesis. Hypothesis, hypothesis, hypothesis. A hypothesis is a statement regarding a characteristic of one or more populations. Hypothesis testing is a procedure based on sample evidence and probability used to test statements regarding a characteristic of one or more populations. All right, so the steps in hypothesis testing, the first thing is we make a statement regarding the population, okay? We might say the proportion of something is this, or the mean is this, or the standard deviation is this. We're going to make some sort of statement regarding the nature of the population. The second part, we collect evidence, so we're going to take a sample, okay? We're going to test our statement. We said the mean price of a house in Oxford was $258,000. Well, we're going to go get a sample of house prices and calculate the mean and see what we think. All right? See if our statement makes sense or not. And then the third thing, analyze the data to assess the plausibility of the statement. That's what I just said. We're going to see if it makes sense or not after we sample the data and do some calculations. All right? The null hypothesis denoted H sub 0. That's read H naught. So this is H naught. H naught is a statement to be tested. It is the statement of no change, no effect, or no difference. It's assumed true unless the evidence says it's not true. So what I just said, if the mean price of house is $258,000 in Oxford, we're going to assume that's true until we find evidence that says, hey, it's not true. Okay? The alternative hypothesis is H with a little subscript of a 1. That's read H1. So H naught, H1. It's a statement that we are trying to find evidence to support. So if I said the price of houses is $258,000 average, and you said, no, it's less than that in Oxford, then we would say our H1 is mu is less than 258,000. If somebody else said greater than, we'd say no, greater. If somebody said not equal to, then it would be not equal to. All right? So with something like that, a lot of times we're talking about less than or greater than, but not always. Okay? So H naught, null hypothesis, is a statement of no change. It's always going to be an equals. And then H1 is going to be either not equal, it's going to be less than, or it's going to be greater than. So let's look at some more information about that. I just kind of talked about this. Equal hypotheses versus not equal. This is called two-tailed. That's when you have a not equals here for your alternative hypothesis. So you can have the parameter equals it for H naught, because it's always equal, no change, okay? And then not equal, or you can have less than, or you can have greater than, okay? For less than, we call that left-tailed, okay? For not equal to is two-tailed. For less than is left-tailed, because if you talk about a number line, numbers that are left of something are less than something else. And then, of course, if we talk about greater than, then that's what we call a right-tailed test, okay? Over here in other words, the null hypothesis is a statement of status quo or no difference. It always contains equality. It always has an equals. The null hypothesis is assumed to be true unless we find evidence that says no, it's not true. And we seek evidence to support our alternative hypothesis. So we assume that our null is true, and we try to find evidence to say, hey, no, the alternative is actually true. So there are four outcomes when you do this. You either reject the null when the alternative is true. So you have two hypotheses, right? If you actually reject the null, reject H naught when H1 is true, then you did the right thing, right? That's a true outcome there. The decision there is correct. H naught was not true. I rejected it. So H1 is true, and that's the one I accepted because I rejected H naught, okay? And then I do not reject the null hypothesis when the null hypothesis is true. That means I say, okay, I do all my evidence. I'm trying to say that H1 is true, but I can't find enough evidence. So I fail to reject, or I do not reject H naught, and it's actually true. That's a good thing, okay? So those are these two scenarios right here, right? The first one was we rejected H naught when this is true. That's this one in the bottom right. And then the second one was this one where we did not reject it and the H naught was actually true. All right, so those are the two true scenarios that work out the decision is correct. Okay. Now what happens though? What if we reject the null hypothesis when the null hypothesis is true? So I do my little testing on my data, and I go, oh, there's enough evidence to say that the price of houses is really greater than $258,000, when in reality it's actually $258,000, right? So then I rejected the null. I said, hey, throw the H naught in the garbage when the H naught was actually true. That's called a type 1 error. When you reject the null when the null is true, that's a type 1 error, all right? That's a type 1 error. Then the other error is do not reject the null when the alternative is true. So if I don't throw H naught in the garbage, I say, hey, let me keep H naught. Let's keep H naught and throw H1 in the garbage when H1 is really true. That's a type 2 error, okay? So if I reject H naught when H naught's really true, that's type 1. And if I do not reject H naught when H1 is true, okay, meaning I keep H naught when H1 is true, that's a type 2 error, and that is denoted over here in our table as well, okay? Just kind of giving us a pictorial representation of that. The level of significance, this is the Greek letter alpha. That's alpha, okay, lowercase alpha. Alpha is the probability of making a type 1 error. That's the level of significance. So they call that alpha, that level of significance, the probability of making a type 1 error. So here, let's talk about, is your friend cheating? This sort of speaks to the essence of why do we hypothesis test, all right? So let's say that your friend wants to play a simple coin flipping game. They tell you, hey, let's flip a coin, and if it comes up, what does it say? If it comes up heads, you win. If it comes up tails, your friend wins, okay? And so your friend flips the coin and gets tails and goes, ha, I won. You're like, okay, that's fine, flip it again. Your friend flips the coin again and goes, tails, ha, I win. And you're like, okay, that's fine, let's do it again. And your friend flips a coin and gets tails again, and you're like, wait a minute, and because your friend's like, I still won. You're like, 3 times in a row? I mean, at some point it ought to land on the heads, right? I mean, it's supposed to be half and half, right, if it's a fair coin. So you say, let's play the game a 4th time, and your friend flips the coin and gets tails, and he starts laughing again. You're like, oh, come on now, let's do it a 5th time. And a 5th time in a row, your friend flips the coin and gets tails again. And you're like, something's wrong, you're cheating. All right, what you doing? Has that coin got a head on one side and a tail on the other? So here's the deal. Here's the approach. To decide whether your friend is cheating, determine the likelihood of obtaining 5 tails in a row. So again, assume it's a fair coin. Assume no change, right? So my H naught is the probability of getting a tail is 1/2, right? It's a fair coin. Really, I don't need to talk about H naught and H. I just want to talk about this is the premise behind it, okay? So let's ask ourselves, is it unusual to get 5 tails in a row with a fair coin? So we're assuming it's a fair coin. If we do, is it unusual to do that? Well, tails is probability of tails and tails and tails and tails and tails. So because they're independent of each other, the first flip doesn't affect the second flip, right? Then they're 1/2 for tails, 1/2 for tails, and we do and, so it's times. So we're actually multiplying 1/2 5 times or raising it to the 5th power. When we do that, we get 0.03125. And remember, 0.05, right? So 0.03125 was less than 0.05, and 0.05 was sort of our understood unusual level, right? That's our understood unusual level. So here, if we flipped a fair coin 5 times, 100 different times, we would expect about 3 of them to fall into this category of 5 tails in a row. 3 out of 100 tries. And your friend just did it right in front of you, right? I would call that unusual, okay? And it's also less than the 0.05. So you have 2 choices. Either your friend is not cheating and just happens to be really lucky, or your friend is not using a fair coin and therefore your friend's cheating, okay? Those are your 2 choices that you have there. Right? So you can just say, oh, well, you're fair, you're lucky, especially if your friend won't show you the coin, right? Then you're going to be really suspicious. So if you never see the coin, then you have to decide, hey, you're cheating or you're just really lucky. So this is sort of the essence of why we do hypothesis testing, all right? So how about forming a hypothesis? How do we form these things? Well, let's look at this A, B, and C choices here. And we want to also determine once we form them, is it two-tailed? That's the not equal. Is it left-tailed? That's less than. Or is it right-tailed greater than? Remember, less than is to the left. That's why it's left-tailed. Greater than is to the right. That's why it's right-tailed. The Medco Pharmaceutical Company has just developed a new antibiotic for children. 2% of the children that take competing antibiotics get a headache as a side effect. The FDA researcher wants to know, hey, is the new antibiotic have headaches at a higher rate, more than 2% or not? Because if it does the same thing and it's a higher accounts of headaches, then why give it, right? You already have something that gives fewer headaches. Forgive me, I had to cough. So here, my H naught, this is for A. My H naught is the proportion or probability equals 0.02, 2%. And then my alternative hypothesis is my proportion is going to be greater than 0.02 because that's what the researcher wants to know. More than. And because it's greater than, we call this right-tailed. Okay? Right-tailed because it's greater than. Right-tailed, that's for part A. And if you look down here in this answer here, that's what it's going to say in there. All right? That's what it's going to say in there. The Blue Book price of a used 3-year-old Chevy Corvette ZR1 is $86,012. Grant wonders if the mean price in the Miami metropolitan area is different from $86,012. All right, so B, here H naught is going to be that the mean, is $86,012. And H1, the alternative hypothesis, is going to be that mu is not equal to that because he just says he wants to know, is it different? Is it different? So is it different? Well, this is going to be two-tailed. Why is it two-tailed? Because different means it could be greater or it could be less. It's on one side or the other. It's on one side or it's on the other. All right, and then for part C here, the standard deviation of the contents of a 64-ounce bottle of detergent using an old filling machine is 0.23 ounces. So you go to Walmart or Kroger or wherever you buy some laundry detergent or you buy something else that's fluid and it's supposed to be 64 ounces. It might be 64.1 or 64.2 or 63.8 or 63.85, right? It might be a little off because the machine doesn't do exactly the same thing each time, all right? And so there's a place in St. Louis, if you go, called Fitz. You can watch them bottle their drinks there. They have peach and cherry and strawberry and watermelon and all these different flavored drinks, and you can watch them go in the clear bottles. It was really cool. We got to watch them do that. Well, the bottle's made to be 12 ounces or 10 ounces or something, and so it doesn't put exactly 10.000 ounces each time. There's a little bit of error. So what they've done is this company has a new machine, and they want to know, does it have less variability? So our H naught here is our standard deviation is equal to 0.23 ounces. And then our H1 is, does it have less variability? So we're going to say less than. So we call this left-tailed, okay? Because it's less than. So we have an example of each one here. Again, if you read through the answers there at the bottom, that's what you will come up with. We have example of each one there, right-tailed, two-tailed, and left-tailed, all right? So let's keep looking at these hypotheses and hypothesis testing and that kind of stuff. So this is the same one as A, the Medco Pharmaceutical Company and the children's antibiotics and the headaches, okay? And it wants us to talk about type 1 and type 2 errors. So it says explain what it would mean to make a type 1 error and a type 2 error. A type 1 error occurs if we reject the null when it's actually true. So here, a type 1 error is made if the sample evidence says, hey, the researcher believes that the proportion is greater than 0.02. That was our H1, right? So we rejected the null. We took the H1, when in fact the proportion of children who get a headache is not greater than 0.02. So that's our type 1 error. We messed up because we rejected equals 0.02 when it was actually true, right? So that's a type 1 error. And then type 2 error, we don't reject that when in fact the proportion is greater than 2%. So that'd be kind of bad for kids everywhere, right, for this antibiotic, because now you're giving something that gives a higher rate of headaches. So you don't, that's the worst kind of error here, I think, just in this situation, because now you're going to give kids something that has a higher incident rate of headaches, even though we failed to reject that, right? So did not reject the null, meaning they say, okay, we left it at the proportion is 0.02, so we're saying that with this new antibiotic it's only 2%, when in reality it's greater than 2% or larger than it says there, right? So that's a type 2 error. And then here, it wants us to interpret the result here. It wants us to interpret the result. So for part A, it says the null hypothesis is rejected, or state the conclusion, interpret the conclusion. So if we reject the null, reject the null hypothesis. That's what A says, reject the null, all right? The statement in the alternative hypothesis is that the proportion of children is bigger than 0.02. So because the null hypothesis equals 0.02 is rejected, we say this: there is sufficient evidence, okay, that children who experience a headache is more than 0.02. There's sufficient evidence to support H1. That's what happens if you do this process and you decide that to reject the null hypothesis is because you got sufficient evidence for H1, the alternative hypothesis, okay? It's because you got sufficient evidence for the alternative hypothesis. All right, so look at B. The null hypothesis is not rejected. So if I got sufficient evidence before to reject it, guess what? We're going to say here, there is not sufficient evidence to say that it's more. So if there's not sufficient to say it's more, that means we're keeping the equals part, is 0.02. We're keeping the null hypothesis here, all right? It's not rejected. That's why we kept it. It's not rejected. And why? Because there's not sufficient evidence to support H1. Remember, you look for evidence for your alternative hypothesis. So you're trying to either support it with enough evidence so you can reject H0, or you can't find enough evidence to support H1 so you keep H0, right? Because we assumed that was true to begin with. All right, so let's look at some problems from the homework in the book here. Here we are given H0 and H1. We don't have to find it. It wants to know, is it left-tailed, right-tailed, or two-tailed, and then what parameter is being tested. So if we look at number 9, H0 is mu equals 5, and H1 is mu is greater than 5. Because of the greater than, that is going to be right-tailed. Right-tailed for number 9, okay? Right-tailed, and what's being tested here? Mu. Mu is the parameter being tested, mu. So let's look at another one here. Let's look at 11. For 11, sigma is equal to 4.2 or not equal to 4.2. So this is two-tailed. Why is it two-tailed? Because it said not equal. If it had said less than or greater than, right? Less than is left, greater than is right. This is not equal to, it's two-tailed. And what's being tested here? What parameter? Sigma, the standard deviation. And then for 13 here, mu equals 120. Mu is less than 120. So let's see here. This is going to be what? Less than says left-tailed, right? Not left. Left-tailed. All right, and that's going to be mu. Mu is being tested there, all right? So right-tailed and mu for 9, two-tailed and sigma for 11, and for 13, left-tailed and mu. All right? So here, determine the null and alternative hypotheses, explain what it would mean to make a type 1 error, and explain what it would mean to make a type 2 error. Remember, type 1 error, let me say it again, is when you reject the null when you shouldn't have, when it's actually true, and the type 2 error is when you fail to reject the null when the alternative is actually true, okay? So you should have rejected the null and you didn't. So single-family home price, according to the National Association of Home Builders, the mean price of an existing single-family home in 2013 was $245,700. A real estate broker believes that existing home prices in her neighborhood are lower. All right, so how do I set this up? Well, my H0 is going to be that mu, not equals. The equals will be on the next part. This is a colon. All right, so mu equals 245,700. Okay? Then H1, mu is less than. Why did I put less than? Because she believes hers are lower in her neighborhood, right? So mu is less than 245,700. That's the two hypotheses. That's part A. Determine the null and alternative hypotheses. H0, H1. There it is. Or there they are. All right, and then part B is what would it mean to make a type 1 error? So let's look at this, all right? A type 1 error. So B right here for this one. That's where we reject H0. So that's going to be where, if we reject H naught, we're taking this one, right? So we're going to say that our conclusion is, right? So the evidence led the broker to reject H naught. So broker concludes what? This is not how they say it. Concludes that the mean price is less than 245,700. Okay. When in fact what? When in fact the mean price is 245,700, right? So the evidence led the broker to say, hey, guess what? I'm going to reject the null hypothesis and say that the mean price in my neighborhood is really less than 245,700. But in reality, the mean price is 245,700, right? So we rejected the null when the null was not actually false. It was actually true. We rejected the null when the null was true. Okay? So then for part C here, explain what it means to make a type 2 error. So here we did not reject the null, right? We accepted that when in fact the other is true. So here the evidence led the broker to accept, or I should say fail to reject. We don't really accept it. We either reject it or fail to reject it. I should never say accept. Okay? To fail to reject H naught. So the broker concludes the mean price is 245,700 when in reality what's true? H1 is true when in reality the mean price is lower. I'm just going to put lower. I'm not going to put damn whatever. All right? When in reality it's lower because that was our alternative hypothesis, right? So we failed to reject H naught. We kept it. We said, hey, we assumed that the mean price was 245,700, so we're going to keep that because I didn't find any evidence against it, or not enough. But when in reality the mean price is actually lower, okay? And number 25, for the hypothesis and hypotheses in problem 17, the null hypothesis is not rejected. So not a type 1 or type 2 error, but write down the interpretation of what happens or the conclusion if the null hypothesis is not rejected. Okay? So if we failed to reject or did not reject the null, all right, then why did we do that? Because there is not sufficient evidence, right? It's either you either have sufficient evidence to reject it or there's not sufficient evidence to reject it. All right? So there is not sufficient evidence, right, to conclude the mean price, that's price, is lower. And I'm cutting some of it off, right? There's not sufficient evidence to conclude that mean price of houses is less than 245,700, okay, in her neighborhood. So there is not sufficient evidence to conclude that it's lower in her neighborhood, okay? And then here I'll just go through these. This should be what we have. You can kind of take a picture of this with your phone and go back and look, kind of compare what they officially use as the wording on these three right here, right, versus what I wrote down. I didn't write it down quite as official as that. All right.